So let's look at the current picture together in this video. We're looking at the region bounded by two lines, and the axis of rotation is going to be x equals 11. So in the current picture, I already sketched the axis of rotation, which is x equals 11, right? And I sketched the blue line representing the diagonal y equals x. And do you know how to sketch the first line? Y equals 6x minus x squared. Just one quick note for you. Uh, you're sketching y equals an expression in x which is quadratic, meaning that there's a x squared term. It has a negative sign, right? If you recall, just for y equals minus x squared, the shape of the parabola is upside down like this. So, which means the shape of this curve should be something like this because the shape is dictated by the largest power term in a polynomial expressions in some sense, especially for the quadratic case. And anyway, so in this case, um, think about this. If you try to solve for the roots of these expressions, you can get what? You can get 0 and 6 as the roots, right? It means this curve should cut the x-axis at 2 points, 0 and 6 respectively. So it means that if you try to sketch it, there's a 0, there's a 6, and the inverse parabola is passing these 2 points. So most likely we are having a parabola like this. And it means basically I'm looking at the region bounded by the two lines like this. So you're trying to rotate this region along the line x equals 11. And you can imagine what kind of solid you're getting. But anyway, in this exercise, I would like to look at the volume formula we can obtain by using the method of cylindrical shell. And please recall the trick regarding the cylindrical shell method. We always have to understand the meaning of a shell. We get a shell out of this picture by taking certain line which is parallel to the axis of rotation, and you take certain vertical line in this case inside the blue region. You try to rotate this green line along the red axis, and every time after rotation you should be getting just one shell like this around the axis of rotation, which is x equals 11 in this case. You see, for each green line you're getting one shell. So now for the shell method, cylindrical shell, we have to try to understand the fact first as an integral formula. Um, the content inside the formula is always like this. And for an axis which is now parallel to the y-axis. So the concept to get the exact volume formula should be close to how we got it. If we imagine that it is actually a y-axis rotation, in that case, for this problem, it is still a dx integration because for y-axis rotation, we usually just do a dx integration. And let's look at the meaning of A and B. A and B now should follow the axis because it's a dx integration. So take a look closer, please. It means A and B are correspondingly the leftmost points and the rightmost points of the bounded region. The leftmost point obviously is the origin, which means A is 0. How to find B? B is gonna be the x value of this intersection of the two lines, right? So let's solve for the B first. So please look at the calculation on the left-hand side. I think I can make 1 equal 2 because the left-hand side of both equations are y, so I can make them equal. And essentially now you have to solve for this equation. So the x value are correspondingly 0 and 5. Yeah. So it matched our expectation because we know the first intersection on the left side is 0. It means B must be 5, right? Yeah. Good. So basically B is 5. So let's come back to the right-hand side. I put it here, B is 5. So what are the remaining things inside the formula for the method of cylindrical shell? It's related to how you understand the shell. First, the second item usually is called h, which is the height of the shell. Please go back to the picture we have on the left-hand side. So if you look at just one single vertical green line, the height of such a cylindrical shell is here. And in terms of length, it is the difference of the y coordinate of the upper point minus the y coordinate of the lower point, right? So let me put it down here. H is the y value of upper line minus the y value of the lower line. Yeah. So I think it's pretty obvious now. The upper line is what? Is y equals 6x minus x squared, right? And the lower line is y equals x. So let's combine them. So the upper line minus the lower line. It should be our representation for the h, which is for the second bracket. So let me put it in here. Or you can just keep it in your mind that in such a situation, to measure the height of such a cylinder, you just always do upper line minus lower line. And because in this case, we have to look at the y coordinate, is the y difference of the 2 points. So it makes sense that we look at the y value as an expression in x, right? So anyway, the remaining thing is about the radius of the cylinder. This is the radius. So what is this length? Let's come back to the original picture, okay? So the original picture, please look at the original picture. Basically, if you have a green line which is vertical like this, the radius is gonna be something like this. That's the radius. That's the radius. So what is this length? We can measure it horizontally as follows. We know that the full length from our red axis to the y-axis is exactly 11, right? Because essentially you're pushing the y-axis to the right-hand side by 11 units to get the new axis, x equals 11, right? You have to use 11 minus the part that we don't want. This part is what? This part is basically the length just measured by the x value of this point, right? And please recall, in this situation, when you're doing it with the cylindrical shell method, this value is exactly x. Because if you go back to the integral formula on the right-hand side, you are basically choosing the green line based on certain points from 0 to 5, right? If you look at the picture from 0 to 5. So basically, the r we can say, we just directly put 11 minus x. X is what? In this case, x is simply the point you choose between 0 to 5. And when you do the integrations, we should cover all the x value from 0 to 5. Essentially represent the fact that we are looking at the shell one by one from 0 to 5. Yes, so please look at the formula here. It is essentially the volume formula of the solid we talk about based on the method of cylindrical shell. That's the end of this video.